much. Welcome to Type uWSGI, press enter, what happens. If this is the talk you're here for, congratulations. If not, you're totally free to leave. And in fact, to give you that opportunity, I'm going to ask you all to do 3 things for me real quick. First thing I'm going to ask everybody to do, it's late in the day. Everybody stand up real quick. We're going to get ready for the talk. Please place your hand over your heart. Take a step to the left. Fantastic. Now you can say that if no matter else what happens, the talk was uplifting, heartwarming, and moving. So let's say you've built a Django app. You're ready to share it with the world. You tell your friends about it, and they think, hey, this thing is really great. But when you deploy it, when you put it out for the world, you shouldn't be using Django run server. You should be using uWSGI. uWSGI, you say. What's uWSGI? And you're a clever developer, so you go and look at the uWSGI project documentation, and it says things about being a proxy. It says things about taking care of protocols and managing processes, that you can apparently write plugins in C, C++, and Objective-C. And this seems very informative, but it doesn't answer the fundamental questions you have about what is uWSGI, what's it doing, and why should you use it. And those are the questions we're going to try to answer today. How does uWSGI handle processes from the operating system level? How does uWSGI handle networking from the operating system level? And then why should you use uWSGI? And to tell you that, I'm going to tell you about why I use uWSGI. My name is Philip James. If you were at DjangoCon last year, you might remember my talk, Frog and Toad Learn About Django Security. If you've been to other PyCons, you may have seen another talk of mine, Type Python, press enter, what happens? And in that talk, I went through what it was on the box, what happens from the operating system level when you type Python and press enter. You may be aware that if you type Python and press enter, you get the prompt at the terminal, but what is the operating system doing under the hood to make that happen? And so in that talk, we talked about how there are these things called processes, and a process that you might use to start Python is a process called bash. Bash starts the Python process by making a copy of itself and then changing that copy to the Python process through a technique known as forking and execing. And that process gets access to these things called file descriptors, which are the mechanisms that are used by the Python process for input and output, for you to communicate with Python and for Python to communicate with you. And that's the basis for our starting point here of how does uWSGI handle processes. And to talk about that, we're going to talk about an app that I created a while back. I couldn't find it anywhere else on the internet. I was really surprised, but CatServe, Cats as a Service. If you are in need of a Cats as a Service in your life, there's a GitHub link that you can go check out. But the app is pretty simple. You go to CatServe, and you get a cat. Now, I did some digging because some people told me to use uWSGI when deploying this, and so I found a uWSGI incantation that would let me run this app from my server. Type uWSGI, press enter, what happens? And what happens if you do this incantation for uWSGI, and actually, quick show of hands, how many people have used uWSGI before ever in any context? Okay, of those people who have their hands raised, how many people knew that you could run uWSGI from the command line, just like blank command line options? Okay, not as many. And that was a realization for many of us as well, is that uWSGI, like many things on Unix systems, is a command. You can run it the way that you would run it outside of a daemon. And so if you type uWSGI and press enter with this particular options, you get a bunch of output. We've condensed some of it, and the line that I really want to point out here is that line at the bottom, spawned uWSGI worker 1, and it has this thing called a PID. Now you might remember from our previous slide that Bash and Python had PIDs. Those are the process IDs. And this line is uWSGI telling you, hey, I have spawned one worker, one thing that is going to run your app, and there's the process ID where you can find it. And so what that looks like, if we were to diagram it a bit, is there is this uWSGI process that you have started. uWSGI forks itself and execs your Python app to make this running Python process running your app. And when a request comes in, now that worker is busy, and it's serving your request. And that's great, but we wanted to add an extra special feature to this web app. You know, we've been hearing a lot about machine learning, We really want to be able to serve you the best cat, not just any cat, but the best cat specifically tailored for you. So I put a bunch of tracking pixels all across the internet to collect data on what is going to be the best cat for you. And we put this behind this beta feature. And we tried really hard, but we couldn't get the time to load the beta best cat for you under 10 seconds. We think we could maybe do better in the future, but right now the page takes 10 seconds. And that's a bit of a problem, because as we see here, if I'm loading the beta, which you can see, and then I try to load the normal home page, well, the home page used to load really fast, and now it's not. And in fact, if we wait the full 10 seconds, we'll see that it's only after the beta page loads with this highly tailored cat for you that the normal home page cat loads. And that's really not what we want. You know, we don't want the beta feature to be basically making the rest of our app worse. And so what we need to do is have uWSGI start more than one process. For Django apps especially, if you want to be able to serve multiple requests at the same time, you need to be having Django run with multiple processes. And so here we've added this -p2 to the end of the command that we're using to run uWSGI. And uWSGI tells us that it spawned not just one, but 2 uWSGI workers with 2 different process IDs. And so if we go back to our beta, we'll see that we can have the beta loading in one window, and the home page now loads independently. Hooray! We've fixed our app again. Going back to the diagram, the way this works is when uWSGI forks and execs, it forks and execs 2 processes. And so while one is busy serving the beta page, the other one can be serving our home page, and our users still get a pretty good experience. So that is basically the core of how uWSGI, and realistically, any other Python web app server like gUnicorn or some of the mod libraries for Nginx or Apache are going to handle this. They're going to fork multiple processes and route requests to each of those different processes. But let's talk about what I mean when I say routing requests to those different processes. So if we go back to that command, I'm passing in HTTP 8000, and that's telling uWSGI, I want you to run this application on that port. And so if we look a bit closer, we're going to look at the middle section of output now, where we see some kind of relevant information that uWSGI is telling us. It's telling us that it's bound 8000 on FD4, it's spawned HTTP1 on a master process 1220, there's some other FDs there, and if you remember from talking about processes at the beginning, we talked about file descriptors being how input and output is connected to Unix processes. And uWSGI is giving us this hint here that these FDs are the file descriptors to these processes that are being passed around and bound to let uWSGI talk to the internet. So let's talk a little bit more about that. Let's say you want to connect to a remote server, and the remote server here is going to be a box, and the way you connect to a remote server is through ports. The ports here are represented as telephone jacks, because a way that you can think about ports on your operating system is that they are like telephone lines that are waiting for things to connect to them. And so you want to SSH into this box. You're probably going to use port 22. If you've SSH'd into a box ever before, you've probably used port 22. If you've used Git, you've probably used port 22 because you've probably used it in SSH mode. And so the first thing that SSH is going to do is it's going to connect this phone line, which is our metaphor for a socket. It's going to connect a socket to port 22, and then it's going to use that socket to communicate through the port to the outside world. Now, uWSGI is doing a similar thing on port 8000, where it's connecting this phone line, this socket, to port 8000, and then using that to communicate and accept connections coming in from outside. There's a little bit more complexity. Both the socket and port functions are happening in a space called the kernel. The kernel is the core of the operating system. It's where all of the interfacing with hardware happens, and it turns out if you want to do networking, you have to interface with hardware at some point. And the processes like SSHD, which is running SSH, and uWSGI, which are running your server, are happening in user land. And there's a mechanism for userland processes to talk to the kernel, and that's through syscalls. Syscalls are these special functions written in C and normally accessed in C that can tie right into the kernel. Let's go a bit deeper. Let's say you're on your computer, you're in Chrome, and you want to connect to your uWSGI server on port 8000. Well, you know that port 8000 is going to be accessed by the kernel, and if uWSGI wants to bind itself, wants to connect to port 8000 so it can receive connections, first of all, the first thing you would notice is if you were to make this connection from Chrome to port 8000 before any of the connections have been done, you would get a connection refused error, right? Because there's no port exposed. The kernel doesn't know what to do with this, so it just tosses it back at you. And so uWSGI needs to issue some syscalls to kind of get things set up so that it can accept requests from your browser. The first thing it's going to do is issue the socket syscall to create that telephone line, to create that socket. And it's going to be passed that socket as a file descriptor, because if you're familiar with the Unix philosophy where everything needs to be some sort of file or at least file-like object, uWSGI needs this file descriptor handle to the socket that it's just created. uWSGI then calls bind, and what bind is going to do is going to tell the kernel, hey, I've created this socket, please connect this socket to the port that I specify, so it's connected to port 8000. And then uWSGI is going to call listen. What listen is going to do is it's going to tell the kernel, okay, everything's set up, ready to go, please expose this port 8000 to the outside world so that I can start accepting connections. Now it's at this point that uWSGI is going to do its fork and execing to create the worker processes. And what's interesting about forking and execing is when you fork and exec a process, you get the same file descriptor references that the parent process had. So both the uWSGI master process and both worker processes have the file descriptor access to the socket that was created for port 8000. And these two worker processes are going to call another special syscall called ePollWait, which is effectively these worker processes telling the kernel, hey, we're both waiting for a telephone call. We're waiting by the phone. As soon as somebody calls the phone, we're ready to pick it up. So now you can make your request from Chrome against port 8000. The phone rings. And both processes try to pick it up at the same time. They both have access to the file descriptor, and they're both going to reach for the phone. But they can't both answer the phone. One of them is going to win first. They're both going to try to call accept, to both try to pick up that phone at the same time, but only one's going to win. And the one that wins is going to get a new socket, which represents the connection from Chrome through port 8000 to the Python worker process. And it's now going to be handling the request, while the other Python process issues the ePollWait syscall again, letting the kernel know, hey, so the other guy won the first time, but if a new request comes in, I'm totally ready for it. And that was a very long, complicated diagram, but that's basically the core of it. Through a combination of syscalls and sockets, uWSGI sets up a connection and then passes references that connection to its worker processes, its child worker processes, and those child worker processes accept the connection to handle the request. So now we get into, now that we've talked about how uWSGI handles processes, and we've covered a bit about how uWSGI handles networking for handling requests, why would you use uWSGI? And the first couple things that I'm going to talk about are not really specific to uWSGI. They're kind of applicable to any Python application server, but a couple are going to be specific to uWSGI, and I'll call those out. So the first thing is code reloading. This is something that the Django run server really can't do. If you are trying to deploy a new version of your code, you've got code running on a service and you want to deploy a new version, you want to be able to deploy that version without shutting down your entire server and bringing it, or shutting down the application server and bringing it all the way back up. So when uWSGI detects that there is new code to be run, when you tell it, hey, I would like to change out the code on the workers, it sends a signal to its worker processes, the hangup signal, sig-hup, telling the workers, hey, as soon as you're done, please exit and reload yourself. And so in this example, we've got one worker that's busy. Both workers get the sig-hup signal. One isn't busy, and so the one that isn't busy shuts down immediately. The one that is busy kind of gets a little notification indicated by the power symbol, hey, when you're done processing your current request, you should shut down because you need to be reloaded. It completes its request, it notices that, oh, I should refresh myself, it also shuts down. Now notice throughout this entire process, uWSGI held onto that socket that was connected to the outside world. So uWSGI never dropped a connection. More connections might have been added to the queue during that time, but uWSGI was always maintaining its presence to the outside world, so from the user's point of view, it may have been a little slower, but they never got the connection refused. So that's reason number one, you might use uWSGI, but that's pretty common. Reason number two, tunability. Earlier, we noticed that when we were running our beta feature, we needed more than one process in order to serve our application well and not have any users be blocked on our beta feature. But why 2 processes? Why not 20? Why not 200? And the answer is uWSGI will let you spawn as many worker processes as you reasonably want, but there's going to be a right number of worker processes for your system. In my testing, a Python application worker takes about 200 megabytes of RAM. If your machine has about 2 gigabytes of RAM because you're running a small server, maybe the right number for you is 10 or 8 if you want to give some wiggle room. But the important note here is that uWSGI lets you tune basically every parameter you can think of to match what your system needs. Again, this one we think uWSGI makes it easier, but it's also something you can do with gUnicorn and a bunch of the others. Security. There's so overall, the Django team does an incredible job with security. In any part of the framework that you would use on a regular basis that actually kind of composes the application, they are very quick to respond to security holes, they release patches quickly, but there's one area of the Django codebase where they have said quite explicitly they will not do any sort of security audit or do any sort of security patches, and that is run server. Directly from the docs, run server is not going through security audits, and that's how it's going to stay. And that might not seem like a huge deal, but just as a small example, this is the headers from an HTTP request, right? If you're familiar with this, this probably makes a lot of sense. If you're not familiar with this, brief overview, you are getting the root page over HTTP 1.1 on host catserve.io, which unfortunately we don't own, but you're welcome to create it and then put our code up on it, and that would be great. And this seems pretty straightforward, but what if you get a request like this? What if there's a layer of your system that interprets the first header, but not the second header, or vice versa? Now, it could be that everything here is fine, but the point to make is that the Django team has not thought about this case for run server, and the uWSGI team has. And so security is one of those things that whenever somebody says it, everyone in the room, including those people who work in security, feels slightly inadequate. It's more that you should be focusing your effort on using tools that have been vetted by people who care about the security of their layer, and the Django team has enough to worry about, and so run server has not gone through security audits, and that's how it's going to stay. Use a different application server. Again, pretty common, not necessarily specific to uWSGI. Another thing that uWSGI or other application servers have in its favor is config files. I showed this because the title of the talk is type uWSGI, press enter, what happens. But many of you who use uWSGI on a regular basis are probably more used to seeing a format like this, that you have in a uWSGI conf file that you can check into Git, you can pass around as text files, you don't have to remember the magical incantation on your server, you can just run uWSGI pointing it at this conf file, and it will do exactly what you want to do captured. And that's great because you get all the advantages of just having a text configuration file that you can, again, check into Git, you can do code review on, you can iterate on over time, and you never have to worry about remembering the correct options. That is a super powerful thing that I think anybody here who's done sysadminning appreciates. Again, not necessarily specific to uWSGI. So now let's talk about some things that are super specific to uWSGI. uWSGI comes with so many features and so many modes of operation that you can probably replace large parts of your existing infrastructure with uWSGI and you may not even know it. For example, uWSGI comes with a static file server. If you want your workers to die after a certain number of requests because you think you have a memory leak and you can't be bothered to fix the memory leak right now, You can set a max requests per worker on the worker, and it'll just restart after a certain number of requests. uWSGI comes with a queuing system. uWSGI comes with HTTP support, HTTPS support, and HTTP2 support right out of the box. It comes with the Harikiri mode, so if a single worker grows to having too much memory, it'll just kill itself and start a new worker. Again, if you've got a memory leak, why debug it today when you can debug it 6 months from now and just have uWSGI take care of it for you? If you want to prove how well uWSGI is doing, you can use uWSGI top. If you want to see exactly where that memory leak is coming from eventually, you can use memory report. uWSGI supports async. And so when I look at this list, a thing I think to myself is, with all these things that uWSGI can do I still need a separate queuing or a static file serving system? Do I still need Celery? Do I still need Redis? What else can you do? So why uWSGI? Code reloading and tunability are pretty common. Security config files and just so many features. If you haven't dove into the uWSGI docs yet, highly recommended. You will discover things that you did not know uWSGI could do. And so that's about it. Special thanks to Unbit, the guy who created uWSGI, who reviewed this talk for me, and my co-creator, the person who helped me write it. He was incredibly helpful at answering questions. If you have any questions, I will answer them now. We've got about 5 minutes. My name is Philip James. I am definitely, I do a whole bunch of things. I've worked in Django and Python for about 10 years. I am definitely available for consulting, especially on security or performance. So if your company is having problems that you think could be solved by someone who's given talks on security or performance at DjangoCons, definitely come talk to me. That's my email address. That is my Twitter handle. Feel free to tweet at me. It is my birthday. You're also welcome to buy me a drink at the bar later tonight. And with that, I will turn it over to, I think we have a couple minutes for questions.
Thanks for the talk. Every single tutorial I've seen on like how to get Django up and running on the internet says you use uWSGI and put it behind Nginx. Why is that, especially if uWSGI can do static file serving? That was, I thought, the whole point of using Nginx.
That's a great question. The reality is that, well, you would have to ask the specific tutorial author why they made that decision. My guess on that decision is Nginx is a technology that more people use as their kind of frontline server, and so more people trust it in terms of being that like termination point and being the kind of the heavy hitter in terms of taking the most load. That being said, I actually do think for most small to medium applications, you could totally 100% get away with just running uWSGI, but there are some things, especially around like certain special proxy configurations, that Nginx is going to handle better. And that was kind of my point with the like list of features is if you if you think all of your use cases can be covered by uWSGI, use uWSGI. A thing that uWSGI can't do quite as well is if you need to be actually, that's not true. It's got plugins. I was going to say there's some languages that uWSGI doesn't handle quite as well, but it has plugins for most languages. People trust Nginx more, I think, is a big part of that. But for small to medium applications, I personally wouldn't have any fear about using uWSGI just out in the wild. And I think people do. They just don't talk about it as much. Hi, Katie.
Hi. Is microWSGI the same as uWSGI but ASCII?
Micro has 2 syllables, U has 1 syllable. In a talk, you're really stressed for time, and so I chose to cut about 100 syllables-ish out of my talk by calling it uWSGI instead of microWSGI. But thanks for the question.
So you've talked about a lot of awesome things about uWSGI. What is the worst thing about it?
The worst thing about uWSGI is there's so much there that trying to actually parse what the docs are telling you uWSGI can do is really tricky. The docs are definitely written from the perspective of someone who is a web engineering professional and could be far more beginner-friendly, especially for exposing some of these cooler advanced features.
Happy birthday, Philip.
Thank you.
Yeah, my question is, so in terms of the process that happens with the communication with the kernel where the socket is open and the port is exposed, how is it different from the run server? What does the run server do under the hood, except for the fact that it can't have multiple workers?
So when I was creating this talk, I was definitely under the impression that run server didn't have multiple workers, and then it turned out that run server sometime when no one was looking added multiple workers. So run server actually does do a lot of the same dance that uWSGI does, but there are things like in that list of features that I described that run server can't or won't do, and realistically, like run server is 100% fine for development, but I trust the team when they actively say, please, please, please do not use this in production, because that's never going to be a priority for them. And I think that I've seen them like actively, maybe not like meanly, but like actively reject packages for making it more production ready, because that's not the goal of run server. But it's doing most of the same dance of like spawn some processes and then have them wait on a socket, because it does do multiple processes now. Who knew?
All right, thank you.
Thank you very much.